Sri Gurubhyo Namaha children, welcome to our online teaching academy Ekalaiva. The topic of this video is Class 7 Science CBSE board and the name of the lesson is Electric Current and its Effect. In our previous class, we have discussed about what is current, what is potential difference, what is circuit, what are all the components important for the circuit, and also importance of circuits. And we also saw about the lighting effect of current, and we also discussed about the types of bulbs and also heating effect of electric current and then the safety devices. So many topics we have discussed. So this is the last part of this lesson, and in this part we are going to discuss about the magnetic effect of electric current. So how does the magnetic field has been produced around the current? We are going to discuss about it. So the learning objective of this video is, at the end of this lesson, you will be able to understand or you are able to state what is magnetic field effect of electric current and what is electromagnet, solenoid and uses of electromagnet and also electric doorbell. We are also going to discuss about how does the doorbell going to work. Okay, now let's start the lesson. So what is magnetic field? How the magnet has been produced around the coil. The magnetic effect of electric current is also known as electromagnetic effect. Why? Because electricity produces magnet, so that is why it is called as electromagnetic effect. And how does it produced? When a compass, you know what is compass, a magnetic compass is brought near a current carrying conductor, the needle of the compass get deflected. So you know what is a magnetic compass? The role of a magnetic compass is to detect the directions, right? Because magnet always shows the north-south pole, okay? And we also know what is magnetic field, okay? Magnetic field is nothing but, you can see in this picture, a region around the magnet where the magnetic force can be influenced. So that region we used to call it as magnetic field. So that how the bar magnet produces a magnetic field around it, same way current is also produces, okay. So this statement was given by a person, Hans Christian Orsted. So in the year 800s, he was teaching a class about the electric current and its circuits. And when he was doing that, and he found that there was a magnetic compass got deflected, and he raised a question: why does it deflected? And because of that, he has done many experiments, and he concluded something that electric current also has the magnetic field. Okay, so how he came to that conclusion? For example, you know the property of a magnet. If you brought the like poles, then obviously they will repel, and if you brought the unlike poles near to them, and they will attract each other. So this is the property of a magnet. Why does it happen so? Because there is a magnetic field around the magnet which will influence the repulsion or otherwise attraction. So same thing, that is why if you brought the magnetic needle near the magnet, and obviously it will get deflect because it has been influenced by the magnetic field. And same thing he observed near the current carrying conductor. So he concluded that current also has the magnetic effect. Now we are going to talk about electromagnet. As I said earlier, why it is called as electromagnet? Because electric current has the property of magnetism, so it is called as electromagnet. Now let us define electromagnet. Electromagnet is a temporary magnet. Why does it call it as temporary magnet? Means only in the presence of current it will behave as a magnet. In the absence of current, there will not be any magnetic field around the current carrying conductor. That is why it is called as temporary magnet, made by the passing electric current through the wires wrapped around the iron core. Okay, you can see here there is an iron nail which has been wrapped around the by the current carrying conductor. It has been connected with the negative and positive terminals of the battery, and once we have done so, obviously this nail will become magnetized and it start to attract the office pins. Okay, magnetic material, whatever may be the magnetic material, it will start to attract. Okay, so it attracts the magnetic substances as long as there is charge flowing through it. Charge flowing through it, electrons were flowing through that. You know what is current? Flowing of charge only, we will call it as electric current. Okay, now we will see how can we make a simple magnet, electromagnet. And this electromagnet can be increased by adding more coils. So which means you can see the picture over here. In this picture you can see the number of coils are very less in number, so it attracts very less pins. And when you compare this one, you can find the more coils, so it will get magnetized, so it will attract the more pins, which means it has more magnetic field around it, so it attracts the magnetic strength of the magnet has been increased by number of coils. And we also can increase the magnetic field, that is strength of the magnetic field, by increasing the strength of the current flowing through that. So if I allow more current to flow through that, and obviously we will get a strong magnet. Now we will watch a video about how can we make a simple magnet.
Shri Gurubhyo Namaha. I am Dashika of class 7C. Today I am going to show how electromagnet is working. I have taken a hairpin and some pins. Now I am going to check whether it is sticking or not. No, it's not sticking. So I have prepared one thing. Materials required for doing this one: a hairpin, wire, battery and tape. First, we have to take a hairpin and coil the wire around the hairpin. Next, take a battery. Negative side, we have to take a one end of wire and paste with the help of tape, and take another positive side and take another end of wire with the help of tape. Now I am going to check whether it is sticking or not. Yes, it's sticking. So the current passing through a wire makes a hairpin as electromagnet. Thank you.
Yes, so the video tells that how can we make a simple magnet, electromagnet. Now we are going to discuss about the solenoid. Solenoid, what is solenoid? How can we define a solenoid? Means it is a tube made of coils, wire carrying electric current, and it behaves as a electromagnet. So here you can see a wire which has been wound around it. Okay, electric wire carrying an electric current, and it is a coil. You can see the coil over here. It has been wounded. Then it will behave, and both the ends of this coil has been connected with the battery, and it behaves as the electromagnet. and around this solenoid you can see a magnetic field around it. This pink color line shows the magnetic field around it. Now let us discuss how can we increase the strength of the electromagnet, that is a solenoid. How can we increase the strength over here? That means how can I make the solenoid very strong magnet? Okay. So there are three possibilities where I can increase the strength of the solenoid. The first one, increasing the number of coils. Okay, so you can see in this picture, in the first picture you can see a more number of coils, and in the second picture very less number of coils. So it behaves as a strongest electromagnet and it behaves as a weakest electromagnet. And then by increasing the electric current through the coil. So in both the coils the input is 6 volt. Suppose if I increase the 6 volt into 12 volt, and obviously it will become a strongest electromagnet. And the last possibility is placing a magnetic material inside the solenoid. So you can see a coil has been wound around the non-conducting material, that is insulator. Suppose if I substitute this non-conducting insulator into with the iron bar, for example, because iron bar is a magnetic material. If I insert the iron bar, then obviously it will become a strong magnetic field. So that is what we have saw about electromagnet. The iron nail has been wound with the conductor. Because of that, the iron nail become electromagnet. Same way, so by changing these things, I can increase the strength of the electromagnet. Now we will discuss about the uses of electromagnet. The very first uses, it has been used in the many scientific instruments like MRI scans, and it is also used to store the information on the computer's hard drive, and also it is used in the cranes to lift the heavy object and also to separate the steel from the junk. Okay. And then it is used in the doorbells and also many household devices like refrigerator, fan, speakers, and washing machine. Okay, and refrigerator, fan, washing machine, and mixers, you can name an appliances, and those appliances they need a mechanical energy, and they are working with the help of motor, and motor will be running with the help of electromagnet. So these are the uses of electromagnet, and now we are going to specifically talk about the doorbell. How does the electromagnet plays a major role in doorbell? So first we will talk about the parts of the doorbell. The doorbell consists of an electromagnet. So here is this is what the electromagnet, and it has a gong. Here is the gong, and then it has a metal strip with a hammer. So here is the metal strip, and this is the hammer, and an adjustable screw, and here is the adjustable screw, and a switch and power source. So here is the switch and this is the power source. This is the parts. Let me repeat again. It has an electromagnet, and then a gong, and then a metal strip, and then it has adjustable screw, and then a power source, and then key switch. Okay. Now we will see how it is working. When we switch on, what will happen? The circuit will get complete. The current will pass through it. When the current pass through it, what happens? This magnet, this particular area will become a electromagnet, because we have studied about the what is solenoid. So here the coil has been wound around a magnetic material, so that what will happen, when the current flow through that, it will get magnetized and it will become a electromagnet. Once it become a electromagnet, what will happen, you can see a pink color thing, hammer and a strip, and this electromagnet will attract this strip, and when it is attracts this strip, what will happen, hammer has been attached with that strip, it will go and strikes the gong. So because of that, the sound will be produced, and when it is go and strikes, what happened, this metal strip has been attached with this, no, so what will happen, here there will be a gap, and that gap will makes the circuit incomplete. So when the circuit is incomplete, what will happen, here the current, the hammer will stop striking the gong, and when it is stopped striking the gong, what will happen, it will go back to its original position, and when it is go back to its original position, again the circuit will get complete, and then it will get magnetized and it will attract this part, and the hammer will strikes the gong. So that is why we can hear the ringing sound as long as the switch is pressed. So this is what the mechanism behind the electric doorbell, and let me tell you, let me show the an animation, and here you can see that this, when the key closed, the circuit is getting complete, so that the charges are started to flow, and because of that this is becoming electromagnet, and electromagnet means it will produce the magnetic field around it, so that it will attract the strip. Because of that, this hammer goes and strikes the gong, and when it strikes the gong, you can see that there is a gap over here. So because of that, the circuit will become incomplete. Again, when it comes to its original position, the circuit will get complete, and it will get, the gong keep on strikes. Okay. So in this video we have discussed about what is the magnetic effect of electric current and also electromagnet, and uses of electromagnet, solenoid, doorbell, how the doorbell works, and so many things we have discussed. So that's all about this lesson. Please do subscribe our channel to get the latest updates, and see you all with the new lesson. Thank you, children.